Okay, so this is part of a larger project, which I can't possibly fit into 10 minutes. So I'll just give you, as you'll see, the puzzle part, and then I won't tell you my solution, even though I have a solution. I'll just mention my background. And again, the formatting kind of screwed it up, so the important part's on the bottom. So I'm a philosopher. I work in philosophy of mind and cognitive science, AI, across a number of domains, experimental philosophy. I've said things about clinical psychology, AI, neuroscience. The thing that really drives me is I like to think about this question of agency and free will, moral responsibility at times, but especially in this context, what neurotechnology can tell us about meaningful agency. Where by meaningful, I mean something like, those actions and decisions that are up to us, morally appraisable, maybe complex, the ones that are more of interest to us. I do have a whole other bit of research that would fit in nicely with what people have said previously today, about bias and machine learning, and maybe how new kinds of bias can arise in machine learning systems. But unfortunately, I'm going to talk about this one, which is also very interesting. So, okay. So today what I'd like to do is just outline a puzzle for you in the literature about decoding motor representations. Essentially, there's these curiously conflicting interpretations that come about when people talk about humans acting in a BCI context versus humans acting in the laboratory. So specifically, brain-computer interfaces, which I'll tell you about in a minute, have been taken to expand agency, even if the subject or the person using it is disembodied or lacks the capacity to act with bodily movement. And then at the same time, in these more basic research contexts, decoding motor intentions has for a long time been taken to expose the illusion of conscious or free agency, however embodied or able to act in a bodily manner the person is. And then the part I won't get to today is talking about how we can solve this. Okay, I have videos and I don't want to show too many videos, but I'll show one or two. So essentially, the best known versions of brain-computer interfaces come from things like Neuralink, because Elon Musk has great PR every single day of his life. And so in 2021, there was this publication about Pager, the rhesus monkey, and essentially he could play Pong, the video game, with his mind. I won't show it to you. I'm going to show you another video. In this case, what they did is they had a joystick and they had Pager, the rhesus monkey, learn to play Pong. That's where they have the paddles and you have to hit the ball off of the paddle. And there's virtual paddle, and he would use a joystick to play this game, and they would give him a smoothie as a reward for playing well. And that's great. And then what they would do is they had actually, via surgery, put the chip in his head that had 2,000 mini electrodes over his motor cortex. And what this would do is it would use machine learning, I'll get to that in a second, to decode based on the neural patterns, how that went along with the movements of the joystick. And then over time, they would disconnect the joystick. He'd still use the joystick. And then over time, he learned to just think how he would move the joystick. So they just completely took the joystick away and he could play Pong very well. And another user of brain-computer interfaces actually challenged him to a matchup. More recently, there's been, I think it was just in March, Neuralink got approval in February from the FDA to have human subjects. And so they implanted a Neuralink device in a human and he can play chess with his mind. It's a little cheap because with chess, he basically thinks like using Lee Chess Online, where to move, which square to move to. So, the idea here, in this case, they use motor imagery. So he simply thinks about moving the mouse and the clicker to where he wants on the screen. And then over time, this program is trained up so that he just thinks this and then the mouse moves. Okay, and there's been plenty of experimental work as well. Okay, I won't go over all this, but essentially I'm going to focus on active BCI. So that's where the user has intentional activity, or their neural activity modulates what the device is doing, as opposed to there is passive BCI. So there's this wearable tech you can get where the device will just sort of monitor your brain activity as you go about your daily life, and then that will be fed into a report, and then you might get something of value from this. But this is where you're intentionally directing, say, your attentional resources to do something in the world. Okay. Very briefly, how this works is that data is recorded, say using EEG or implanted electrodes from areas of interest like the motor cortex. That data is encoded from the recorded signals, and this is used with machine learning to get a predictive model over the training set. And then later in the experimental set and the clinical usage, the neural activity is decoded using the predictive model, and then those signals are read out and translated into attended effects in the world. Okay, this has been taken as really promising and exciting. Obviously it is, I'm not denying that. So one, we could learn a lot about brain function and cognition. People who are excited about transhumanism, you know, that might be something. It's also have clinical import, obviously. So there's a number of clinical populations, those with ALS, paralysis, maybe locked-in syndrome. This allows them to, so to speak, act in the world. And I just threw this in there. There's a lot out there about the clinical promise, the safety perils of this, including Sussex own discussing this. Okay, this might be a case of extended mind, something that I would love to talk about, but I don't have time to say. So I'll save that for questions if you have questions. And indeed, users experience a sense of agency when they're using BCI. That's akin to the embodied outcome case in the lab. I can't say too much about that, but if you have questions about how do they measure that, happy to say. Okay, where's the pessimism here? Weirdly enough, you know, since the 1980s, there has been this whole program in the lab of neuroscientists who have been trying to decode motor intentions or intentions to act. And I'll just show you one quick example and give you a quick context for it. Okay, let me give you just an idea of what's going on here. So these are researchers who are interested in understanding whether we can find intentions to act in the brain, localize them or somewhat partially localize them. And in this case, this is a patient who has had electrodes implanted based on clinical needs. And what they're going to do is they're going to play a game. And for this game, the person has to try to raise a hand that the experimenter is not predicting they will raise. So they either raise their left or right hand. And then if the experimenter guesses correctly, then the experimenter gets some money. If they fool the experimenter, they get money. And the way that the experimenter is operating this is crucial, is they're using a machine learning program that's taking the neural activity over the motor cortex and trying to predict whether it's left or right hand raise. And you'll see the experimenter is very good at this. They win 83% of the time. Since we don't have a lot of time, I won't go too much into that. Oh, wait. Am I supposed to? Okay, now, 2 minutes. All right. Okay, so hopefully what you get from this, and this is part of a larger body of work, this experiment that goes back to the 80s called the Libet paradigm, which is in the lab, we can essentially find predictive signals of when people are about to act or how they're about to act. And historically, in the science of this has been taken, and also in the pop versions, this has been taken to undermine agency, precisely because the onset of this electrical signal from the brain that you can measure seems to occur at least a third of a second before people seem to be aware that they're intend to move at all. And this has been taken to be very agency undermining, that there's this illusion of conscious agency or free agency. Now I don't have time to get into that. I know a lot too much about that. I'm happy to talk about that. But here's the weird thing. Brain-computer interface technology has been, heralded as expanding our agency, right? However, you might run this perhaps pessimistic argument against it. I'm not a pessimist. Maybe I can get into that later. It goes like this. The experimenter, right, is in that clip you saw, is predicting the action plan of the subject prior to the subjects having at least a phenomenology of intending to move. The BCI device is working on the same neurotechnology and the same kind of areas. And so it's akin to the experimenter reading out the online measured action plan. So the device is predicting your intention to move. If prediction prior to phenomenology is agency undermining, and this is just the tip of it, right? Then it would be that BCI decoding your intentions is also agency undermining, even if there's a match between what the device does in the world and what you intend to do, even if you feel as though you're in control. Now, I don't have any time to say something optimistic, but I'm very optimistic that we do have an agent in the loop, or a person in the loop, a human in the loop, if you are. I will just briefly show you how solving the puzzle would go. I think there's good reason to think that users of this BCI technology are acting. I think, one, they're acting in the sense that they have this mental action of forming an intention of what to do. But I think it goes beyond that sort of mental action, and that but I think we might have to embrace something like extended cognition, that we can take the device as sort of a vehicle of their action plans, so that the device itself can carry sort of cognitive states of the agent and act for the agent as the agent. I think we can say that. I think getting there is kind of difficult and is longer than I have time to talk about today. But in essence, I'm optimistic about it, but there's this puzzle and how people have been interpreting this. Okay, thanks.